Welcome back to our videos talking about the t-distribution. And in this one, we're going to get a look at sort of the statistical inference side of the t-distribution and how we can apply this, much like we did with the chi-square statistic and the chi-square distribution, where we computed a chi-squared value and then used that to make an assumption about whether or not the claimed population standard deviation was reasonable. We will compute t, which will be x bar minus the stated population mean over the sample variance divided by the square root of n. We know that this has a t-distribution. And what we can do with this is look at then what is the stated value for mu and decide if we think that is reasonable. If t is too big or too small, the assumed value of the population mean mu is not reasonable. And what do we mean by too big or too small? If there's no acceptable bounds specified, we will do the same sort of process as we would with the chi-square statistic, in that we want to accept a 95% chance, 95% of the values, right? And so too big or too small, we would have t of 0.025, and so we want it to be, it would have to be past t of 0.025. Too small, it would have to be less than t of 0.975. In between that would give us a 95% chance. Anything in between that would be considered acceptable. So if in doubt, you want to allow 95% in the middle and cut off the two tails of 2.5%. If it's not specified in this example that we're going to do, it is in fact specified though. A chemical engineer claims that there is an average of 500 grams per milliliter of raw material in some substance. And so to check the claim, we take a sample of let's say 25 batches. A sample of 25 batches, all right? And if the t-value, I made a grave mistake up here. Whoa! I made a grave mistake here. I made a big mistake here. Well, actually, you know what? This is okay. This is okay. I did not make that big of a mistake. Something that we can do that I didn't really realize when I was writing this out is, remember, the t-distribution is symmetric, like the normal distribution, okay? And so if I know one of these bounds, I know the other one because of symmetry. They're just the negative. So the way this problem is phrased is as follows. If the t-value falls between negative t of 0.05 and t of 0.05, we accept the claim. We accept the claim. Because remember, when we look at the table in the t-distribution, t of 0.975, that's not available for us in the table. But because the t-distribution is symmetric, this is equal to the negative of t of 0.025. Okay? That is equal to the negative. So when in doubt, we can use those values. In this case, we've got a little bit more wiggle room. This problem is suggesting 5% to the right and 5% to the left. That would be a 90% acceptance. Okay? suppose the sample yields an sample average of x bar equals 518 grams with a sample standard deviation of 40. What do we think? Do we think the mean is actually 500? Do we think the mean is actually 500 here? Well, let's compute our t value. Remember, t is x bar minus mu over s divided by root n. So t, x bar is 518 minus mu, which is 500, divided by s, which is 40, over the square root of n. What's our sample size here? We have a sample of 25. And so we need to run this number through a calculator here. This is just 18 divided by 40 over 5, and that is 2.25. That is our t-statistic. All right, so we need that. Now, is this acceptable? Is this reasonable? Well, let's think about what we have. We want it to fall between negative t of 0.05 and t of 0.05. So we have a sample of 25, so we've got 24 degrees of freedom, right? N minus 1 degrees of freedom. We need to go ahead and look at the table and find the value that leaves 5% of the area to the right. T-table. 5% to the right. That's the second to last column. What is our degrees of freedom? 14. So we got to go down to 14. That would be 1.761. 1.761. Is that right? 1.761? 24 degrees of freedom? That's not right at all. That was 14 degrees of freedom. Where's 24? Right there. 1.711. 1.711. I knew that didn't feel right. 1.711. 1.711, okay? So what's the acceptable range, right? If the t-value falls between that and the negative, so the acceptable range is negative 1.7 to positive 1.7. The acceptable range is then negative 1.711 to positive 1.711. All right, well, what's our t-statistic? That's just 2.25. It's not in the range. 2.25 is not in our acceptable range. It's bigger than our upper bound. So we would conclude that the stated population mean of 500 is not reasonable. Not reasonable. It is unlikely, very unlikely, that that is in fact the true population mean. Very unlikely. That'll do it for this example on the t distribution. We will see you in the next video.